Welcome to CustomCells. We will start our little production tour today. We will start with introducing you to some of our cell formats we are currently developing and producing for our customers. These are special formats, so beside the standard automotive cells, we do cells for special applications in smaller numbers, prototyping for customers. Then we will start the tour throughout the processes, show you the electrode production. We will start with the coating, show you our inline measurement systems, explain you a bit about what we are working on at the coating line, what we are focusing on improving our processes. Then I will show you all the different electrodes we coat at the calendering process step, because there we store the intermediate products before they go into calendering. So it's a good chance to give you an overview how a typical production week at CustomCells could look like, all the different electrode formats, chemistries maybe that we are coating. Of course, we can build a bit the link to the products, but yeah, at least you can get an overview of what we're doing. And then we can go to the assembly process where you can see, okay, how do we assemble all these different cell formats? How do we do this prototyping? What machines are we using? Yeah.
All right.
Great.
Let's go.
Let's go. Basically, this is CustomCells. When we were starting, this room was mainly empty. We had only a small room in the back with one single coating line, which we are currently used just for prototyping and some early development. And then step by step we introduced additional process steps. We introduced a dry room, an additional larger coating line. We had the calendering, and then we ran out of space, so we needed to go in the second floor. And there we have the slitting process. Yeah. And yeah, we decided to do everything not in one major room, but separate all these processes in different single environments where we can control the environment conditions, like moisture, like cleanliness, and have a full control about the environment, as it is also a very important part of the process.
So what you can see is that we basically focus, of course, on pouch cells, because it allows us to be more flexible in the production and also in tailoring the size and the specification towards the customer's needs. But we can basically do everything from, those are very small cells which can be implanted into the body. So ranging from 300 milliamp hours to really large automotive-like cells, which can go into electric vehicles to having about 80 amp hours of capacity. And what we also use as a testing vehicle is especially this cell format. So here we can do tests of, for example, different materials, different cell chemistries in a smaller format. But this format can also be used for very specific applications, I would say, regarding special racing stuff and so on. So we can really tailor, you can take them. So these are, of course, the lightest ones. They are super small and have super small tabs. So yeah, as I said, they can be implanted into the body. I mean, this is not a final cell, this is still more like a prototype, but to directly test in the size of the later application, this is really helpful. Regarding the cylindrical cells, so we can currently not do them in-house. So we are only developing currently the chemistry, and our this is basically some of the future goals, to also build a line to build up these 46XX.
Because I mean, cylindrical cells like this would be a mass market cell.
Yeah.
What application would you foresee for them, for CustomCells?
Yeah, it's again more high performance EV, so they are going until really high energy densities, but still having a certain power density. So basically the best of both.
We have two of these coating lines. This one is currently set up for production because we wanted to show you how we start the production, because this is the most interesting part about it. Once the coating line is set up and running, it's basically black ink put on foil. Yeah. What you can see here is a primed aluminium substrate. And basically, what kind of chemistries do we coat on this line? We do everything from LFP, LMFP. We do high silicon, very high silicon, graphite, and of course NCM 90+. Talked about all the different chemistries and also substrate foils, for example, we can process here. We have, of course, primed aluminium foil, but we can also do, at the moment we do all the coatings on this line. We can also do, for example, very thin copper foils. So we can do 6 micrometer, for example.
Okay. At what speeds?
So this is, of course, a very low speed. We can do, typically we do maybe 6 meters per minute. We can do faster, but it's a quite short line. Mm-hmm. You would need to optimize all the drying conditions, etc., for a certain product. And typically we just work in a very comfortable setup, as we are varying chemistries, designs so much, right?
I understand, yeah. So you're operating more on the pilot scale in terms of processing speed of electrodes?
Yeah. Okay. Exactly.
But therefore, what quality and special materials?
Exactly, and therefore we have also, like, even though it's a really small pilot line, you could in theory operate the line with like minor measurement equipment, but we have installed a lot of equipment to ensure quality and get the insights in the product. As we are varying so much chemistries, we are interested in also characterizing how does this product behave at pilot scale, because this is very important that we not only get the performance out of the material, but also the scalability of the design. And what you can see here, for example, is the exact area weight distribution. This is the electrode length, this is the electrode width, and what you can see is a complete heat map. With the blue spots, the electrode is too light, the red spots, the electrode is too heavy.
This gives you already a system, or shows you that there must be a systematic error at the slot
Exactly.
die.
Exactly.
Some agglomerates or whatever that are deviating the flow.
Yeah.
Yeah, it's cool.
It's our calendar, where we basically densify the electrodes. This can also vary, like from just basically ironing, flattening the surface, up to really strong densification, where you have the typical calendering issues. Here you basically can see what I meant when we talk about flexibility, right? So we introduce you to the different cells and different formats we produce, and I said, or Anja said, that also the chemistry differs, and this is what you can basically see here, right? So different electrode designs for different formats.
We can basically change this format according to customer specifications in the end. And we can, of course, also more or less easily switch between different separators, and also, of course, the electrodes are flexible, so this still allows us to also test different chemistries, for example, in this format. So not only in the small format you see, but also to directly produce EV cells, for example, with different anode materials or different cathode materials, and directly test them in the really application format. Mm-hmm. Between 50 70 layers per electrode, so we can also have over 100 layers in total.